In the previous video, you took a look at how to convert from different units of pressure, temperature, and volume. In this video, we're going to take a look at Boyle's law, which is a law that describes the behavior of gases, and specifically with regards to volume and pressure. So we're going to take a look at a gas and see what happens if you increase the volume of that gas. What happens to pressure? And what happens if you decrease the volume of that gas? What happens to the pressure? So let's take a look at a simulation and see if we can see this occurring. So I'm going to keep, in this simulation, I'm going to keep the temperature as constant. I'm going to keep it as at 325 Kelvin. So let's take a look at our volume as we start and our pressure as we start, right? So the volume currently is 820 liters. The pressure is 0.98 atmospheres. If I lower the volume just by a little bit, so if I lower that volume to 520 liters, the pressure has now become 1.54. It has increased, right? And what happens if we increase our volume? So when you increase your volume, the pressure decreases, right? And this is all that Boyle's law is summarizing. Boyle's law states that the volume and the pressure have an inverse relationship. So as volume increases, the pressure is going to decrease. And as volume decreases, the pressure is going to increase. And you can summarize this relationship by writing it in this way. So volume has an inversely proportional relationship to pressure. And this can be summarized in Boyle's law, which is a formula that we're going to use in our calculations. And this formula looks like this. P1, so pressure initially, times V1, which is the volume initially, is equal to P2 times V2. Right? So the initial pressure and the initial volume is equal to the the final pressure times the final volume. So given any three of these variables, you can solve for the fourth variable. So let's take a look at an example like this. Before we do that, let's sort of summarize what happens to volume and pressure as either changes, right? Why is it that this takes place? So when you increase the volume of a container, the pressure decreases, right? When you're increasing the volume, you are essentially increasing the space in which those particles can move in. And when they have more space, they tend to collide less, right? And when they collide less, they tend to hit the walls of the container less as well, which means that there's less pressure exerted on that container, right? So imagine that I have this larger container and it has 10 particles. I'm going to draw 10 particles here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But imagine what happens if I decrease the volume here. When I decrease the volume, the pressure increases. Why is this? Because when I'm decreasing the volume, I'm giving the particles less space, which means that they're going to collide more often and exert more pressure on the walls of the container, right? So if I have the same sort of type of container and I have exactly 10 particles again, but this time in a smaller space, they are much more likely to collide with each other, right? And when they collide with each other, they also exert a pressure onto the container that it's in. So let's take a look at an example where you can use our calculation. So here's a situation. A weather balloon with a volume of 2.00 times 10 to the power of 3 liters at a certain pressure rises to an altitude of 1.00 times 10 to the power of 3 meters, where the atmospheric pressure is measured to be 60.8 kilopascals. Assuming there is no change in temperature or amount of gas, what is the final volume of the weather balloon? Now, you're going to see a lot of questions like these, especially as we learn with more and more gas laws. You're going to see more and more questions. Now, it's very important for us to identify the variables. As soon as you identify your variables, it will be very obvious which of the gas laws you have to use. So let's just sort of write out all the information that we are given. So weather balloon has an initial volume. So the first volume is this, 2.00 times 10 to the power of 3 liters. And it has an initial pressure, so P1 is 96.3 kilopascals. Now it says they rise it to an altitude of 1.00 times 10 to the power of 3. Now we can write that down as something that they have stated to us. But you're going to see this is not really anything that we use in our calculation, right? And at that altitude, the atmospheric pressure, so P2, is 60.8 kilopascal. Now take a look at what the question is asking. They're assuming that the temperature does not change, and they're assuming that the amount of gas does not change either. We are asked to find the final volume, so V2 is equal to question mark. So let's take a look at our formula. Our Boyle's law formula says P1 times V1 is equal to P2 times V2, right? According to this formula, if you have 3 of these variables, you can easily solve for the 4th one. So I can solve for V2. Now, I really like in these formulas to rearrange the formula to what I have to solve for, then plug in the numbers, right? So P1 times V1. I'm solving for V2, so I have to move P2 to the other side. Currently, it's being multiplied, so when I take it over to the other side, it's going to be divided. So this is my formula for V2. I'm going to plug in all my numbers. So P1 is 96.3 kilopascal. V1 is 2.00 times 10 to the power of 3 liters, all divided by 60.8 kilopascal. And this is equal to V2. Now let's take a look at our units. Our unit of kilopascal cancels out. Now this is going to be something that you want to keep in mind for the next few gas laws. When you've got a relationship like this with our initial and our final, you just want to make sure that our units are consistent. So it doesn't have to be that the pressure has to be calculated in kilopascal. It could be ATMs, as long as both P1 and P2 are measured in that same unit, right? So if one of these was ATM, I would just convert the other one so that they're both the same unit. So in this case, they're both kilopascal, which is good because now they can easily cancel out. Now the unit that I have left over after the units cancel out is liters. And the answer that I'm going to end up with is 3.17 times 10 to the power of 3 liters. Now take a look at our sig figs. I've got 3 sig figs all throughout the question, and I've got 3 sig figs in my answer. Another thing, let's take a look at the situation here, right? So the initial pressure was 96.3 and the final pressure was 60.7. The pressure decreased. So does it make sense? You should ask yourself whenever you have an answer like this, does it make sense that my final volume is greater than my initial volume? It does, right? Because when pressure decreases, volume would have increased. Okay, that's it for Boyle's law.